Okay, let's just figure out what exactly. All right, so this page is done. This page 1 and 2 is done. Okay, so we'll start at 3. Page 3 says explain whether it's a positive, negative, or no association. Interpret the scatter plot. So this one is, if you draw the line best fit, right? If you draw a line here, that is definitely a negative association or correlation. Okay, and so I'm going to write that this is negative. A strong negative, right? Because all the lines are tied together on the line. And it's interpret it. So it said, so shower time, the longer your shower time, the less hot water you're gonna have. So the longer your shower, the less hot water you'll have. So notice that as one increases, the other one decreases. This one, there's no association. So for the second one, number 2, I'll change colors. So it's no association. So no association. And we can stop right there. Right? There's really no relationship here. This one is positive. And let's see. Okay, right there as best as you can. So you should have some points as best you can on above the line and some below, the same amount if you can, right? And this is a strong correlation, strong positive. And let's see what they're relating. They're talking about age in years and your height. So the older you get, or the older you are, the taller you'll be. You will be. So positive, strong positive, and you notice that as one increases, the other one increases. So that's what makes it a strong positive. Okay. 2, this one says a teacher wants to know if there is a relation between the amount of time they study and the score that they get. So let's first of all look at a scale here, the clear objects. So test time. So you got to figure out which one is your independent and the other one which one is your dependent. So your test score depends on the time that you study. Okay, so test scores will be your dependent, or your y, your output, and your x, your independent, or your input, will be the time that you study. So let's look at the time. Let's see, 10. We can go. Let's see, 10, 20, 30. Yeah, so we can make this. That's 0. That's 10. That's 20. That's 30. That's 40, and that's 50. So our scale will be by tens in the time, and our scores, we need to go up to 80 and 90. So let's see, 20, 40. So we're going to make every 2 20, 20, 40, 60, 80, and then this will be 100. And then we can fit everything. So 30 minutes, if you study 30 minutes, your test score is 82. So here's a dot. If you study for 20 minutes, your test score is 75. So about here. If you study for 45 minutes, your test score is going to be a 91. If you study for 50 minutes, your test scores are 95. If you study for 65, if you study for 10 minutes, your score would be a 65. So if you study for 30 minutes, your test score will be 85. So right about here. If you study for 40 minutes, test score was an 87. So just about here too. If you study for 15 minutes, the test score is a 70. If you study for 35 minutes, your test score will be an 88. Right here. And if you study for 25 minutes, you score for 25 minutes, your score is an 80. Right here. Well, I see a correlation here. Strong, positive. Okay. Interpret the scatter plot. What kind of relation does it have? It says that the longer you study, it seems the longer you study, the higher your grade will be. The higher your grade will be. That's what it looks like. All right. Use a scatter plot to predict the test score of a student who studied for 55 minutes. Well, and then for a kid who studies for 15 minutes, I mean, you might want to draw 55. So that's 45, 2 boxes. Here will be 60, right? So 55 is here. So let me just move it up here, and we can use our graph. So it looks like if you study for 55 minutes, we can predict for 55 minutes, according to this, 55 minutes, it seems that the test score might be 100. Okay. And this is a strong positive. Okay. Moving down to the second one. Let's see what does it say it has to do. Let me just clear a few things. Clear annotation, clear objects. Number of hours spent on math homework during 1 week, and the math grade for 11 students. Okay. In Mr. Smith's algebra class are plotted to the right based on the plotted out. What is the correlation between the time spent on homework and exam grade? So it's very similar to the previous problem. Let's see if we can draw a line of best fit. Line of best is about here. Okay. So there seems to be that, again, like the previous problem, the longer your time spent on homework, the higher your grade will be. Higher your grade will be. Let me just adjust the line there. The line of best fit should be around here. And tomorrow, we'll try to figure out the equation, the best equation for that particular line. Okay. And again, this is a strong, what would you say, strong positive? Just strong correlation, right? Strong correlation, strong association between the number, the time spent on homework and the exam grade. So there seems to be a correlation between those two. Okay. All right, so we've done that page. Okay. I think we have to do this one. So, question says, let me clear objects. Positive, negative, or no association. Interpret the scatter plots. Well, let's take a look at the first one. This one is definitely a negative one, right? So this is a negative. Line. So negative correlation, strong negative correlation, right? Between what? And this is the more time you spend on more time, so we can write more time more time what does that say? Water draining from bathroom gallons. So hang on a second. Water draining from bathtub. So Water draining from bathtub. Or time, I don't know if that's time spent or time that it takes to, so as time increases, right? Because as time increases, the water draining decreases. Water draining from bathtub, the water draining decreases. Okay, so when one goes up, the other one goes down. That's what makes it a negative correlation. This one is no association. Okay, you can clearly tell. Association. Like, there's no way you can draw a line of best fit here, so there's no association here. This one definitely looks like a negative correlation, right? Like that. And it says here as hours spent on TV time increases, what is it that decreases? Test score decreases. All right, so one goes up, the other one goes down. When it's positive, both will go up. So this one is definitely positive. Let me draw a line of best fit, just like that. And as the number of games played increases, what else increases? Your total points also increases. So that kind of makes sense, right? So that's that. All right. So again, like I said, very simple, right? Very very simple. Let's graph this. What are we graphing? Puzzle competition, the time, and the number of pieces. Well, so logically, if the greater the number of pieces, the longer it's going to take for you to complete the jigsaw puzzle, right? So let's graph this. So if there's 100 pieces, it's right here, it's going to take you 35 minutes. So 35 minutes about here, right? You have 60 pieces. 60 pieces is over here. So that's 100. So 60 is here. It's going to take you 20 minutes, which is a little bit lower. If you have 500 pieces, which is around here, it's going to take you 175 minutes, which is about here. If you have 750 pieces, which is about here, it's going to take you 350 minutes. So just about here. If you have 1,000 pieces, it's going to take you 395 minutes, so about here, right below 400 minutes. If you have 800 pieces, it should take you 270. 270 is going to be about here. And if you have 75 pieces, which is about here, 175, it's going to take you 25 minutes, which is going to be right around here. So, alright, so there is a correlation here, positive. Alright, so interpret the scatter plot based on the shape of the distribution. So this would be as number of pieces. Sorry about my handwriting. Pieces increase, the time to complete increases as well. Suppose Dave has 650 pieces. Well, 650, predict the length of time. Well, let's find 650. So here, this is 600. This is 800 right here. So that's 700. So 650 is this where I'm putting these dotted line here. So, and so it's about there. And that looks like 250. So 650 pieces would take approximately 250 minutes according to our line of best fit. Okay. Car park on the car owner parked the track the value of a car over time, which description best represents association between the car value and the age. So as your car ages, your value decreases. Right? And I guess we're talking about just your everyday car, just like mine. It's not a collector's item or anything, just a regular car that you take every day to work. So here's the line of best fit, right? So, and it shows that as time progresses, right, usage, wear and tear, the value of the car decreases. So this is a negative, strong negative correlation, right? As the car gets older, the value decreases. Its value decreases. All right, so when it's negative, remember, one goes up, the other one goes down, and when it's positive, they both go up. What does this one say? Did sales of hot cocoa increase or decrease with higher temperatures? What is the correlation between the temperature and cups of hot chocolate sold? So it looks, let's see, the colder the temperature, the greater a number of hot chocolate that you sold. Except that, I don't know, I guess, could we call this an outlier? Right, because it was 80 degrees and they sold about 7 hot chocolates. Well, maybe, but let's keep it without that. So, what's the relationship? Well, the hot with higher temperatures. Temperatures. Oh my God. Temperatures. Sales decreased. Okay. So the hotter it was, the sales decreased. The colder the temperature, the higher the number of hot cocoa sold. So what's a correlation? It's a negative correlation. Negative correlation. Right? So in this one, sales are up, are increased when temperature decreases. Okay? Decreases. Okay. We did this, and I think we have to do the last. No, I think that's it. No, we have to do. All right, we have to do this one. For each scatter plot shown below, determine if you think it's linear or non-linear. So this one is definitely non-linear. Not linear, it's a U-shaped. It looks more like a parabola. This is also non-linear. Right, it looks like an exponential relation. Okay, so non-linear. They're both non-linear. Okay, I don't think we did this. So here are boxes loaded with apples. All the boxes are the same size, but have different number of apples in them. Okay, so you go apple picking. Each box is weighed, and the weight is compared to the number of apples in the box. Draw a line of best fit. So that it intersects with the y-axis. Okay, so make sure. So they're really asking us to intersect. So line best fit should be, yeah, there, right? So again, as best as you can, have some points above the line and some points below the line, like an equal amount, best as you can. Okay. So weight of box plus apples, okay, in pounds. So when there's 10 apples, look at the weight, it's about here. The weight's about 6 pounds. When it's 20 apples, we can read this. So let's right here. When it's 20 apples, it's about 9 pounds. So that's what we have information wise. So we did A. B. This is a positive or negative. This is a positive association. It looks like a strong positive association, right? Where as number of apples increases, number of apples increase, the weight of the box also increases. Weight of box also increases. Estimate the y-intercept. Well, the y-intercept, I mean, since we created a line, the y-intercept is right here. So that would be, let's see, 2, halfway would be 3. It looks like 2.5. So the y-intercept, or as we also call it, B, is 2.5. 2.5 pounds. Okay? So the y-intercept, so I'll write it over here again, y-intercept, according to the line of best fit that we just drew, or B, y-intercept B is 2.5 pounds. How can you interpret your answer from seeing the context of this problem? So if you think about it, here at 0 apples, why is the weight 2.5 pounds when there's 0 apples in the box? Because the y-intercept in the context of this problem represents who? Represents the weight of an empty box, right? It has no apples. So 0 pounds, this weighs 2.5. Sorry, 0 apples, this weighs 2.5 pounds. And how do we explain that? Because we're talking about the weight of the box. Okay. And now we have the last problem. Middle school want to visualize the association between how many days a student is absent and their overall grade. Okay, we think there's a relationship between how often you're absent and your grades. The results are shown for 80 students in the scatter plot below. All right. Draw a line of best fit. So it looks like there is a negative relation. Okay, and let's draw the line best fit. The line best fit, there we go. Right? It wouldn't be that one. That's definitely not the line best fit. This definitely would not be it. So you want to put it somewhere where it looks like half of the data is above the line and half the data is below the line, or you want to draw the line where it's closest to all the lines, right? So this line right here, where it is, okay, is the line of best fit. Why does it make sense that it is a negative association? Because the greater your absences, right? The greater your absences, it seems that the lower your test score is, the lower your GPA is, GPA is. Right? So remember, in a negative association, when one value goes up, the other value decreases. And in this case, when the absences increase, what happens to your GPA? It goes down. Are there any outliers? Yeah. Make it. Here's our outlier. Okay. This one, it said he was not absent at all. Look, he was at like 4 absences, but his GPA was still lower. So it didn't really follow the trend here. So the trend here says, you know, as the number of absences get higher, you your GPA goes down. So this guy has about four absences, and if you look at most of the other kids, the other 80 kids, anybody who has 4 absences, they're in this area here. Let me just shade that for you. They're in this area. Oops. Let me shade it right here. So anybody 4 absences seems like they're great. Why is this not? I'll just circle it. 4 absences, 5 absences. They should have that grade in the 90s, mid 90s, high 80s. Except that this guy here, except for this guy, even though he only has 4 absences, his GPA is still way under the rest of them. That's it. I know that's simple, but that's it.